Dear friends, welcome back to the channel. In this video, we'll be diving into Krypton, a war game from OverTheWire, which is designed to sharpen and improve your knowledge on the cryptography, in encryption and decryption skills. Before we get started, make sure to subscribe to my channel and give this video a thumbs up. It really help the channel grow. Now, let's jump in and start hacking away through this fantastic Krypton series. The level I'm going to do will be level 4. I not only show you how to use the normal way or online service to get this level done, but to be more important, I will spend much more time on manually decrypt or manually get the level down with Python script. So then we can head over to cryptanalysis. First of all, we need to SSH to the target. Let me grab the previous command to begin with. And we need to provide the password of current user Krypton 4, and we can get it from notebook. We can copy and paste in here. Now we're in the target machine. As before in this series, without any hesitation, we can cd to the directory of Krypton, and because the level we are dealing with is Krypton 4, so we can go to this Krypton 4 subdirectory, and maybe I can press keys Control, Shift, and L at the same time to clear the screen. Then we can get a bigger space on the window. Next, we can run ls with options of A, LH altogether. And we can get readme and also some other files. So I think we need to have a look at the readme. Always readme give us the guide to do this level. Okay. So here, a very important encryption algorithm, which is this one. What's the name? Yes, Vigenère Cipher. Although we have already, if you have already followed my channel, you know that we have already encountered such encryption a lot. But at that time, we can use online service to decrypt the encrypted text very easily. Okay. However, I'd like to take this opportunity to explain what this, Vigenère Cipher behaves, or what this kind of encryption is done. Okay, now let's scroll up. You more than likely used frequency analysis. The previous level, we use Python to analyze frequency, and then we can match the most frequent letter to the English language, and then we can get we can decrypt the cipher text. So far, we have worked with simple substitution ciphers. There have also been monoalphabetic, meaning that using fixed key. So for each letter will be substituted by one letter. Okay, so this would be 1-to-1 mapping of a plain text to cipher text. However, another type of substitution cipher is referred to as polyalphabetic. So in this case, or with this cipher, one character of P or plain text may map to many or all possible ciphertext characters depending on its position or placement. So an example of this cipher, polyalphabetic cipher, is called Vigenère Cipher. It works like this. So if we use the key, this is the key. This key consists of 4 letters or 4 characters, and this is the plain text. And then, so how to conduct such encryption? So the P, we need to add P and its key, and also the key. The first letter in this key is G, right? And then we add, and of course, actually, of course, the string cannot be added, right? However, we can add based on index. For every letter in the alphabet has its index, right? For example, let me show you. In Python, we can launch Python. We can create the alphabet, import string. So like a string uppercase. So if you want to get the index or the position of each letter, we can use index. For example, like uppercase P, and then, its position is 15. It's a 15. Sorry, where? Yeah, here. Yeah, here. So this should be P, should be 15. Okay, 15. And the key, the first letter in the key is G, and also we can get its position or index. So we can index G, and then we can get the number 6. So this is the index of the G letter in this alphabet. Okay, you can print out this alphabet, and then we need to add them together. Sorry. So 15 add to which one? 15, 6, and then the result would be 21. And then we can get the 21, the 21, or we can get the letter which is located in the position of 21, because index starts from 0, so we can put 20, and this should be U, and '21, yeah, 21, and then this is V. This is V. Interesting. Sorry, here I think the letter in this alphabet would be for index of not 20th should be 21. Sorry about this, and then we can get encrypted string V. So this is how this Vigenère cipher works. Okay, for example, the second letter. However, for each letter in plain text, we'll get a different encrypted cipher letter. This depends on the location. Okay, and also because the plain text will always be longer than a key. For example, the goat, and then will, for example, when it comes to the C and then E, right? However, the key length is 4. So this will start from a G again. Okay? Of course, the space, we can ignore space. Space, we will not do anything. Okay? So I think I've already explained what, this Vigenère cipher is, or how this Vigenère Cipher is doing. Okay, so next, we are disconnected. We need to connect to the target. Again, we can copy. Next, I'm going to show you the first way, which is also the easier way. We can use online service to decrypt this cipher. But I think this involves two steps. First of all, we need to get its key, and then we can use this key to decrypt the cipher text. CD Krypton 4, and we can, another file. I forgot to take a look at hint. So this frequency analysis will still work, but this time the frequency analysis should be done differently, because just the reason I mentioned earlier. Each letter has a different encrypted or cipher letter depending on its location. Of course, if the letter in the same location or in the same shift position, they should be converted to the same letter, to the same cipher character, okay, or encrypted character. And so now we can cut out the first cipher text. We can copy, and we can use this site. This site, I've already used this site a lot to conduct decryption. And we can select which one? So this one, because we know the number of letters, or the key length. Key length is 6, okay? As you can see over here, the key length is 6 letters. Yes, 6 letters. So now we can decrypt. Of course, I'm not robot. Oh, sorry, I think I forgot to copy the cipher text. And then I think we can decrypt to see whether we can get, yes, we successfully get its key. And we can copy and to put over here, and then we can copy the message which contains the password for the next level. Okay, and we can copy and put over here. Or not. And then we can decrypt, and then we can, I think we can get the decrypted result. Very easy. Of course, next I'm going to turn your focus on the Python. We need to use Python to get this level down. Okay, let's go back. So how to do? Although we cannot conduct directly frequency analysis, however, for each group, and in this case, the group contains 6 letters because the key length is 6. For example, the first letter in the first group, and also the first letter in the second group, they will be using the same key, right? For example, let me for example, I'd like to copy anything, and we can copy. You know, I assume this is plain text. Okay, and I can remove space. So for each 1, 2, 3, 4, 5, 6. So for and the key, the key is like HIJKMO, whatever. Okay, so for the same position in all group, maybe we have more. Have more group for each letter in the same location, in the same position in each group. There will be, using the same key. For example, in this case, the key letter is H. And the second letter the second letter in each group will be using the second letter in the key. Okay? So we can take advantage of this to crack the key. Okay, so how to do? Let me implement it with Python, and we can call it like we want to get, this is the ciphertext. I want to get the all first letters. For example, the first letter, this case, this is the first letter in the first group, and this is the the first letter in the second group. I think you have already got my point. Okay, so I'd like to extract all first letters from all groups, and each group has the same length. The length is 6 because the key length is 6. And then I will conduct frequency analysis. Okay, let me show you how to do in Python. We can call it like we can extract letters. Okay, so this I think we can call it a font 1. We can copy from here, copy, and I think this we need to remove the space, so we can call the function replace. We can replace space with empty string. Okay, so now how to do? And also we can define the shift variable. So when I run this program, the first time I want to get the first letter in each group. So I will assume the index starts from 0. So the shift we can set to 0, and we run this program the second time, we can set the shift to be 1, and then we can get the second letter, right? So how to do? We can, we can so we also can set another variable result. And for now, we can set it to empty. So now we can for index from range, not from, in range from 0, length of font 1. And then we can utilize the modulus operator or remainder operator. So if index percent 6, maybe we can define, it's okay. If you want, you can, use the variable to store the 6th value, but I think it's okay. I think you can understand the program. And if index %6 equal to index, for example, the index 0, it means that this letter, the first letter, and modulus 6 would be 0, right? So we can extract this letter. And if this index go ahead or move forward, index equals 1, and then the remainder would be 1, and this case, this if statement would be false. Okay, so now, and this can be ignored. We need to get the next first letter. Okay, so how to do? We can result, and so we can found 1 index. Okay, so now we can print out this result. Okay, we can run it. Oh, we do not need to SSH to the target this time. Or now, Python. We can. Oh, what I'm going. Python 3. Extract letters. Why? I think it's not correct. Find the 1 index. Sorry, I got this place wrong. This should not be index. This should be shift. Okay. So for example, 0. And if we want to get the second letter in the group, and then the shift would be a 1, right? So now we can run our program one more time. And we can get this string. Okay. So now what are we going to do next? We need to conduct frequency analysis, and we can make another Python script, frequency analysis. This is very easy. So we can, input string input. So please, or input string here, and next, we can create the dictionary variable, and this dictionary will store letter and its corresponding frequencies. Okay, so frequency or occurrence. So how to do? So we can letters, frequency, and for now, set to empty. Now we can loop over this string. Of course, this string should be this one. Okay, so now if letter is already in this dictionary, we can call, or not, this should be letters, frequency, keys, and then we can add the value, okay, by 1. So letters, frequency, and its key name is letter, and we can augment by 1. Else letters, because else means right now the dictionary doesn't have this letter. Okay, so letter 1. Now we need to sort this dictionary, and we can call it sorted letters frequency, and we can call the function sorted. And then, this sort should be based on values of each key value pair. Okay, so how to do? We can give the argument of iterable dictionary letters, frequency, and items. Okay, and the key, we can use lambda anonymous function. The item 1 index means value, and also we want to be descending order, so reverse to be true. And then I think we can print out these sorted letters, frequency. Now let's run the program. Frequency, and we can input string. We can copy and paste in here, and then we can get the, this list. And so the G ranks most. So we can go back here. Yeah, here. So here cipher letter is G, and G we can get its index or location is line. And as we know, in English language, uppercase E or E ranks the most. I have already explained in the previous level. So we can, so the plain text letter is E, and its index is 4. Okay, and so at the beginning I have already explained how this Vigenère cipher works. So we have already got a cipher letter, and also we have already got plain text letter. Then we can deduce its key letter. So this key letter would be, 9 minus 4. 9 minus 4 equals to 5. And the 5 is, the letter for 5 is F. So as you can see, we successfully get the first letter in this key. So similarly, we can get all 5 letters in this key, and ultimately we can get the key. Let me do it now. So we just set the shift to this one. We can set it to, this time we can set it to 1. It means I want to get the second letter in each group. Okay, so the second one, and now we can run this program again, and we have already got all letters, and each letter is located at the second position in each group. Okay, and now we can make analysis. So we can copy this string. Okay, so in this case, the V ranks the most. So we can V ranks the most, and its corresponding plain text, will be same, will be E. So V, its index is 21, okay? And then we can 21 minus 4 and get or equals to 17, and the 17 is R. So we can get the second letter in this key. And now we can move to the second or next position, the third position. We can save it and run this Python script again and conduct frequency analysis one more time. You got my point, right? And then the I is mapping to E. Oh, sorry. and its index is 4, and the R, or not R, the I is 8. Sorry, 8. So 8 minus 4 would be 4, and we can get the E as well. So the third letter has been retrieved. Okay. So similarly, we can set the shift to be 3, or the third letter in each group. Okay. So run this program again and analyze frequency in this output. And O, so we got the O, and O, its index is 14, okay? And similarly, E is 4, so 14 minus 4 would be 10, and 10 is K, okay? Would be all uppercase. So the 10, and now we can run this program. And we can copy. We just repeat. Maybe you can make this these two Python script to be better, but I just want to explain how our program would be like. So the I here, and okay, I think also this would be, would be E, and so the last one we can run one more time, and we can copy. And the C, so C, the index is 2, and E is 4. So 2 minus 4 would be -2, and this means 24, right? And this would be Y. So now we successfully get its key. The key should be FREKEY. FREKEY. I think it's correct. Yes, right? FR, yes. So next we can make another Python program to, to decrypt the cipher text. Okay, so now we can new Python file, decoder, okay, and cipher text. We can input, so cipher text, and also we can, remove the space in this string. Very easy, because this method will, replace the space by empty string. Okay, so now we can define the decrypt text. For now is empty. And also, sorry, I think we need to, create the character set. So we can import a string and uppercase. So maybe I can call it, yes, uppercase. Letters, doesn't matter. And we can call it, or we can call string as uppercase. And this returned value would be all uppercase characters. Okay, so now how to do, and we can, we can for Next, also we can store the key to this variable. Okay, and then we can for index in range from 0 to the length of ciphertext. But for now, how to do. We need to, I think, we need to get the index of, maybe I can use the comment. So index of letter in cipher text, right? The index, for example, the cipher text. So I think we need to get its cipher text. Where is ciphertext? Maybe we need to connect it again. And this should be the ciphertext. We can copy and paste over here. So it means that we need to get index H in this alphabet, right? Or in this collection. For example, H, its index would be 7. Okay, and then we need to get the index of letter in key, and this should be at the same position. For example, if the index, for example, the ciphertext. So what's the cipher? Yeah, this is ciphertext. The first letter and also the key. We also need to get first letter in the key. Okay, so and then we need to make calculation. We need to use this value to minus this index, and then after we can get index, and then we can get its corresponding letter in this alphabet. Okay, let me show you. So how to do, and we can decrypt text. I think we can uppercase letters, and here we need to use square brackets. Now the problem or the key thing is to give index. For example, if we can get the index of 13, and then we can know the letter should be N. Okay, so how to do? We can, so we need to get the index of letter in the cipher text. So how to do? We need to use uppercase letters, and we can use the function index. Index method, not a function, can return the letter, the letter in this collection. Okay, so this should be cipher, and we need to give the index. Okay, so this one, this part will return the letter itself, for example, the H, right? And then, the index method will return its position or index. The position H would be 7. Okay, and now we need to minus what? The index of letter in key. Also, we need to use because here index means the location or the position in the alphabet. Okay, so we also need to use index method, And next, we need to, give the letter. However, not like a ciphertext, the key length is less than or is shorter than the ciphertext, right? So how to do? Here we can get, and first of all, we need to get its letter. So we can key and square brackets. Here we can use the index and the percent of 6, right? Or key or length of the key. So it means that if the key comes, for example, if this index, maybe it's not good. We can use maybe index. Maybe will get you confused. We can just use the I, right? And here we can use the I. I think it would be better. Otherwise, you will get confused, right? So the I. And, if here, this part will get the letter. For example, now in the first iteration, the I is 0, right? And 0, for this part, we'll get this letter in the ciphertext. And we'll get this one, the first letter in the key. However, when it comes to, if the, ciphertext is always longer than cipher, and for example, would be 7, here, 7, the 7th position. So in that case, we need to start over again from F. So this is the reason why we need to use remainder operator, okay, or modulus. And now I think we have already calculate. And also, of course, here we need to use parentheses and use another modulus operation. Okay, so now I think that's it. We can print out decrypt text. We can run this program ciphertext. We can copy from here. Can copy. Sorry about this pop-up window. As you can see, we successfully decode or decrypt the ciphertext. Hopefully, I've already explained every key, step. Okay? So I think that's pretty much it. I'd like to see you in the next one. Bye. Have a nice day, please.